So this diagram then takes it to the next level. So just let me recap and I'll read the question. If the DC firewall is used to segment certain workloads, what are your thoughts on where the gateways should be configured for the secured networks, on the firewall or on the switches? So this is always one that comes up. It kind of depends, because if you put, I would suggest that if actually it's quite a good place to move to the next place. So what I tend to do is I would effectively split my network or my data center network into zones, because I've been early in my career, I've been stung by this based on, I worked for an IT outsourcing company who had a shared service, and they had Cisco 6500s as a shared service with multiple fiber ports, and the service module that they had in there was a firewall services module. Now, so let's just say that firewall services module was here. The firewall services module had multiple different interfaces on it, and they were actually default gateways for, sorry, let me rewind. The firewall services module was split into multiple contexts. So let's just pretend that these two, this was context 1, as in firewall 1, and this was context 2, right, for customer 1 and customer 2. And these are all the data center subnets. So this is all like one management domain, and this is all one management domain. So even though it's on a single physical chassis, we've got a Cisco 6500 core switch with, let's say, 2 or 3 fiber line cards in it, which then go downstream to 4500s that have got the port capacity. So if this is the 4500, and then it's just a VLAN up to each of these interfaces, and then we have like 4 subnets down here. Now, if we've got, let's just say VLAN 1, 2, 3, 4, and VLAN 1 needs to talk to VLAN 2, then in order for that, I know VLAN 1's a terrible choice, but you get where I'm coming from. Not literally VLAN 1, VLAN first service has to come up here and through the firewall and back down to talk to VLAN 2, because the default gateway is on the firewall. Now, if the default gateway is on the firewall, the more rules and the more the more default gateways that are on the firewall means that if you have a host-to-host security policy, which most data centers do between zones, it means that if you've got, let's say you've got 20 data center subnets, that means that you need 20 default gateways on that firewall. Now, if you then start looking at, like, well, we've got a web, a middleware and a database, or web application database tiering model, then in order for those to talk to each other, they have to go through the firewall via that orange line. How that has an impact on your data center firewall, your back-end firewall, is that certainly on the firewall services module, we got stung because it was a shared service. There was multiple contexts all using this approach, and how it maximized the resources on the firewall services module. And the reason for that is it was because if you go on a web interface or a Java interface and configure via ASDM or something like that, and you put in 50 hosts in the source and then 50 hosts to the destination and 8 ports, let's just say it was Active Directory 1 talking to Active Directory 2, 1 being this down here and 2 being here, and they need to talk to each other via the firewall, and they've got 50 servers in them each that all have to talk to each other on 8 ports. That generates 50 sources times 50 destinations times 8 ports number of ACLs on your firewall here, and it maxes out, or it can max out your throughput and the amount of rules and things like that. So a very short answer to the question, which was basically where would you put the default gateways on the firewall or the switch? The way that we got around that in the end is we had to work with the customers in the new design, which was kind of like a long-term project. But what we basically done is identified application zones. So it's kind of what you see here. This is a simplified version of it. But what we have here is we have this back-end data center firewall, and then we effectively have the data center back-end as one zone, so that's like the trusted zone, and then we have the semi-trusted zone, which is the WAN, and then we have an untrusted zone, which actually sits outside the front-end firewall. But the red switches, the blue switches, and these switches here are all the same physical chassis. How we got around it in the case of what I was talking about is effectively what I drew here. So we had let me change the colour, it's a bit easier to look. So we had the firewall, so still the same, but instead of having a default gateway, we still had a layer 3 interface, but it would be into VRF trusted, and then another one into so this is the same customer. So this is customer 1, the context. They would be into VRF untrust. And then you might have another one, you might want a VRF, and then what that means is, like, because Active Directory servers were able to talk to Active Directory servers and whatever else they needed to talk to in that design, you basically, then your security zone becomes, let me just find another colour, green. So if we say, and then we had another routed link to infrastructure, VRF, and then you had servers in here, they don't need to pass through the firewall, so that cuts down on the resources that are taken in the firewall up here. But if this was an AD server and this was an AD server, and they both needed to talk to something in the DMZ, then that would be a group of servers that were to talk to maybe like one server in the untrusted zone, if that makes sense. So my recommendation is that don't put your interfaces on the firewall. I think there's some solutions like from VMware and things like that, and there's more virtual firewalls. So for virtual server farms and things like that, you can put virtual appliances and things like that, which can make it a bit less resource intensive. But I don't see that deployed a lot, to be honest. Hopefully that answers your question. Going back to this one, just to recap on where we were. So we talked about chassis-based switches split into multiple device contexts, and this is how that would look. I covered some of it there actually in the diagram. So this is how it would actually look in a data center. So now we're talking about the evolution to a modular data center, and we have a few different zones here, which I touched on a second ago. So we've basically got anything north of here is effectively the data center or the LAN, right? Anything, I find a blue colour. Probably should have just aligned them. So anything, and then that would be like the back end. Sorry, so that would be like an internal VDC, for example, on an Nexus chassis, or the the leaf switches that were pictured in the spine leaf topology. Here we have like a semi-trusted DMZ. So the reason that it's semi-trusted is it's still private connectivity, but it goes into the global wide area network. So this is you know, like remote sites coming from different regions and having to get into the data center. And this is effectively, if I take that stuff off and we focus in on the data center, you'll notice that we have spine leaf topology here. So these are the spines, and these are the leafs or the top of rack switches. I'm not going to cover it too much today, but you'll notice that the top of rack switches also have a backdoor link. So where I've drawn in those like red lines and the red, that's the spine leaf for the Ethernet side, and then that continues towards like the blue server. But the blue server will have a connection into those top of rack switches, but it'll also have connectivity into the SAN, like or the storage area network. And then you'll see we have SAN connectivity between the sites for replication and things like that, as well over a DWDM link. So that is like what I've seen more in maybe like the last 5 to 7 years, where we have front end back end firewall, front end back end firewall, and then we have different zones. Data center, DMZ, and external, and then and also sometimes semi-trusted. But to be honest, I don't normally see the WAN segmented from the data center. There's normally a WAN aggregation switch in the data center as well. Now, moving on to the next part, which is, you'll see some commonality here between what we talked about here and what we're about to talk to. So just to be clear, the DC evolution, it's went from chassis-based to modular with spine leaf, but with no software-defined networking. And then we move to a software-defined data center.